All right, well, welcome to our first online lesson. Um, this is going to be a wild ride because we don't know exactly how it all works, but here we go. This is going to be the day one of 8.1.1. We actually have 2 days for this lesson that were scheduled, so I'm going to have 2 short videos, one for each day. In this one, we're talking about which tool is more precise. So you're going to be doing an experiment where we measure our classroom, the length of the classroom with a ruler and also with a longer tape measure to see which one is more precise. Do the lengths of objects you measure or tools you choose to measure will affect how precise your measurement is likely to be. In this section, your class will explore this question by analyzing the results of an experiment. As you work with your team, think of the following questions. Well, your team is me. What am I measuring? What unit is being repeated? And what can I do to make my measurements more precise? As you look at this icon up here, this is kind of giving you an idea of what our pictures might look like to decide about variability and how our measurements are different from our peers, our other groups that are measuring today. 8.1, which tool gives more precise measurement? Have you heard the expression measure twice, cut once? This advice refers to the care professionals such as carpenters and fashion designers need to take the measurement to measure precisely so that all the parts of their creations fit together correctly. Careful, correct measurements also ensure that they do not waste materials. Doesn't matter what tool they use to make their measurements. Imagine using 2 different tools, such as a 12-inch ruler and a continuous measuring tape. To measure a length of your classroom or the width of a basketball court in inches, how might the measurements that you get compare? So we'll be using a 12-inch ruler, and I don't know if you can see this in the little video screen of me, but we're going to be using a ruler about this big, 12-inch ruler, and excuse me while I find the tape measures that you were going to use for this. Miss Yan, what did I do with the tape measures?
Look at that. Huge. Long.
Okay, here's the tape measures that we're going to use. All right, thank you. Let's let that go, and we'll measure the classroom with that in a little bit. All right, so discuss the following questions with your team. Well, for you, I guess you're just going to have to think about how you might answer these if you had a team. What would you get, or would you get the same measurement with each tool? Why might the measures be different? Shouldn't they be the same, or should they be the same? Which tool do you think would give more precise measurement? That is, one that is closer to the true length of the classroom. So pause your video for a second and ponder those questions.
With the punches, I think it should be the same.
You think they should be the same?
It should be the same.
Well, I think they should be the same, but people might be more accurate if they're using a longer tape measure, don't you think?
How do you know? Because if we think they are the same, then how do we know the long one gonna be more precise?
All right, well, we're going to have to find that one out. And what the heck do they mean by the true length of the classroom? I suppose that means the exact length. Is that even possible to get exact? Okay, moving on here. Welcome back to the video. 8.2, now you and your class will gather data to test your ideas about the precision of measuring with the same length with 2 different tools. Your task, had you been here, would have been this. As directed by me, measure the specified length in the classroom to the nearest inch twice, each time using a different tool, a 12-inch ruler and the measuring tape. Although you will share your tools with your team and work together to make the measures and record properly, each person in the team would measure the length twice, once with each tool. So
Mr. Punches, one, we have to do it twice again.
measure twice, cut once.
Would be enough?
It should be, but we want to make sure that we did it right the first time. So we're going to measure a second time. And what we're actually measuring is the length along the wall in the classroom that has the windows. And so
Thank you. Now I understand.
Miss Yen had some data that was from last year's students that we could share with you so that we can continue doing this work today. So the data would look something like the following here. In just a moment, let me see where I'm headed with this. So these were the 22 different measurements done, one with a long measuring tape and one with a ruler, and both were measured in inches. So one of the teams got 330 inches with their measuring tape, another team got 340 inches with the tape. But when it came to the ruler, there was 330 inches, and then somebody got 346 inches. So there's definitely some difference in the measurement, and that's what we're going to be analyzing next. So we have our measurements that we're going to work with. Problem 8.3. Once your team members have each made their measurements, compare the results within your team by answering the following question. Which tool seems to measure more precisely? All right, well, let's look at that. Which one seemed to measure more precisely?
Mr. Punches, would you please show us again, one more time, what it really looks like, the ruler in inches, and what it really looks like for the long term? So
Sure.
we can compare.
Okay.
They are different.
So our ruler in inches was this big. Just a regular 12-inch ruler. The tape measure, this tape measure was 120 inches long. That means that we can use this tape measure to measure longer spans. So when you look at that data, if we had to answer the first question, which tool seems to measure more precisely? Well, that seems to me maybe the longer one would measure more precisely because we have to do fewer changes. So if you have a lot of different measurements and you have to add them all together, you could add wrong, or you also might get little gaps in between the measurements that might extend it or maybe even shrink it if you don't measure really accurately with that little ruler. So I'm thinking maybe the tape measure might be more precise. So if I were going to answer a question for 8.3 here, let's see if I can do that. Hold on one moment. So for 8.3, I might say the tape measure seems more precise. Now, what do you think the actual length of the room is, and how do you decide? Well, if we were going by the tape measure numbers, between 330, and these numbers are in order from least to greatest, by the way. Thank you, Mr. Punches. 330 to 341, where would you put the actual lengths? I don't know, I might put it in the middle of those somewhere. Maybe a lot of 336s, some 337s. I'm thinking maybe like 336, 337. That'd be my guess. So if I were going to answer that one, the length may be 336 to 337 inches based on the data from the tape. It's near the middle. And I'm sorry for my writing. Not easy to write on these screens. Which tool do you think gave you a better answer? So I think the tape measure is better because the data is not so spread out. Period. So if I go back to that data, and you can pause now to catch up to your writing, but if I go back to look at that data, it goes from 330 to 341 versus 312 to 346. The inches in a ruler are spread out much farther than the tape measure one. So I think these might be more accurate. All right, head it on. Once you've paused and got caught up to your writing, go ahead and then start your video again. Let's take a look at 8-4. Add your data to the class data table. Okay, we're still using this data here. Examine the sets of data, record any initial observations you can make. All right, initial observations. The spread of the data for the tape measure is less than the spread of the data for the inches for the ruler. I think that's a good observation. So let's see here. The spread of the data, of the tape data, is less than the ruler data. Are there any measures that look very different from the others? These extreme values are called outliers because they are far away from most of the data. But what could you do to help you see the outliers better? So when we look at that data, that 312 seems awfully low compared to the 330. But the 312 might not be that low if you look at it only within its own data set. Because these are spread out pretty evenly, it looks like, as I go through the data. So 312 could be an outlier, maybe. 330, maybe. I think it's going to depend on a graph, and we're going to have to take a look at a graph. So I'm going to write this down. 312 might be an outlier. But we need to look at a graph. Maybe we should use a box plot or histogram. Box plots and histograms are good for looking at the spread of the data and how far apart the data is, and if there are any outliers that are far away from that interquartile range, the one that you've done some homework problems on not too long ago. So let's get on to part C. Sometimes an outlier can reveal that an error or misunderstanding has occurred. Decide as a class if any data needs to be deleted or corrected due to an error or misunderstanding. So if 312 was an error, I suppose we could delete that piece of data. I don't like to take data out of a set unless I'm sure. So I think we're going to leave that in right now, and we will look at it after we've done our graph and decide. But if that was an error, I suppose somebody could have forgotten or added wrong maybe and didn't add an extra 12 inches that would have put them up here into the group a little higher. Maybe they missed one of the feet or forgot that they had counted one of them wrong. That's possible. The tape measure, less likely that they made an error because they may have only had to do the entire tape measure 4 or 5 times across the room. maybe only 3 times to get across the room. So getting back to problem C, we're going to say we're not going to delete any data. Problem D, what is the range of each set of data? How do the ranges compare? And for each set of data, what is the median, first quartile, and third quartile? So it looks like they're trying to set us up for making a box plot. So let's go do that work over by your data, and you can call this 8-4D. So they want us to find the range and the median and the quartiles. So the range is when you take the biggest number minus the smallest number. So if I take 341 minus 330, the range is going to be 11 inches. The median is the middle number when the set of numbers are in order from least to greatest. Since there are 22 numbers here, I want them to find after right after the 11th number, so in between the two 11s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The median is going to occur here because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the two 11s, which puts that right in the middle. So the median of 337 and 337 is the average of them, which is also 337 inches. The lower quartile, quartile number 1, is going to be the middle of the bottom 11. So 11 is the same as 5 plus 5 plus 1. So let's go 5 from the left, 5 from the right, and find the 1 in the middle. 1, 2, 3, 4, 5. I think this is going to be the 1 in the middle. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is the lower quartile. That'll be 336. And the upper quartile, that's going to be the same way. 1, 2, 3, 4, 5. That should be this one. 1, 2, 3, 4, 5. Yes, 339 inches. Pause your video and you go try to get the data for the bottom set by yourself. Let's see if you can do it. I need range, median, quartile 1, and quartile 3. All right, let's see if you got it right. Bringing your video back online. The range is going to be 346 minus 312. So that is going to be 34 inches. That's a pretty wide range compared to the one above it. The median, doing the same trick. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is going to be right here. Oh, that's right in the middle of 334s, so that'll be 334 inches. The quartile 1 is going to be 1, 2, 3, 4, 5. It should be this one. 1, 2, 3, 4, 5. 324 inches. And quartile number 3, 1, 2, 3, 4, 5, should be here. 1, 2, 3, 4, 5. Yes, 340 inches. Did you get them right? I hope you did. Okay, keep that data because we're going to need it for day 2's lesson. So we will use that data for problem 8.5, which will be on the next video. Your homework that I need you to try and complete on your own is 8-8 to 8.12. And I will have the answers to that homework at another time. But for right now, try that tonight for homework. And don't forget to attach it to your Google Classroom assignment so that I can see it when you're done. Thanks for listening.